Again, thank you for joining us today for this fourth webinar in our technical series. This one's entitled An Introduction to Digital Terrain Modelling with Allplan Engineering. When we sat down and came up with these ideas, we thought, we needed to bring all of these aspects together, and digital terrain modelling was one of those obvious ones. Maybe we should have done it sooner, I don't know, but certainly the aspects of reinforcement and bridge modelling that we've covered to date, they all fit in with one integrated workflow. So we'll begin now with the presentation. So today's agenda, we're just going to briefly do the introductions, aims and objectives about Allplan before we kick off and get into digital terrain modelling in earnest. We'll have questions at the end and then just wrap up and tell you what else we can do for you. Okay. You'll notice that there is a question panel in your GoToWebinar applet. If you can ask your questions through that panel, then my colleagues in the UK will pick up on those and they'll let me know what the questions are at the end, and I'll answer it from where I am today, which is in a lovely sunny place called Graz, which is in Austria. So yes, truly a worldwide organisation. The other thing I should let you know is that this webinar is being recorded and it will be available at a later date from allplan.com. Those of you that have missed this webinar, shame on you, but never mind. You'll be getting an email from us again asking you to go to or contact myself requesting locations for this, but it's at www.allplan.com. Right, so just a small piece of background. I'm as old as I look, yes, definitely. Over 30 years in industry, various technical roles from civil and structural engineering perspective. Been with Allplan for just over a year now, and then prior to that, 8 years with Autodesk, and then over 25 in consultancy. Hopefully I do know what I'm talking about, and my main areas of interest has always been workflow between disciplines, and obviously anything that facilitates that workflow is high on my agenda when it comes to integration. So what we're going to do today, more or less exactly what we've said at the beginning. We're going to introduce the concept of digital terrain modelling within Allplan. We're going to show how this works with both alignments and structures. Because it's an hour long, there's not an awful lot we can do, but the aim is to give you a taster for what Allplan can do with regards to digital terrain, how it works, the options that we've got, and so on and so forth. Okay. So first of all, just a quick poll with regards to what solutions possibly are you using for digital terrain modeling. Okay, so recognizing that there are various solutions out there, also recognizing that there are other solutions as opposed to the ones that I've listed on the form there. Those of you that are, and I wish we could do this a little bit better, that are selecting other, if I could ask you in the question panel to let me know what you are using besides an Autodesk and Bentley solution, that would be brilliant, because again, it helps me to understand exactly where you sit with regards to the solutions that you are actually using. Okay, that it's not going to be used for marketing purposes. It's just going to help me understand who I'm speaking to. Okay, brilliant. Thank you very much. So I'm going to close that poll now and share the results with you. And as you can see, we have a vast majority of existing users on the call today. And then we've got mainly then sort of an Autodesk type solution, which will be probably based around Civil 3D and possibly Revit. Minor uptake on the Bentley with Inroads or something similar, and bringing up third place is the 17% of other solutions. So invariably, we tend to focus on the two main competitors to ourselves. But again, it's interesting to see who we're also up against in other markets. Okay, thank you very much. So the next poll, again, is to understand workflow. So is this part of modeling buildings or infrastructure or both? So buildings is yes. I suppose this is, so buildings is yes, infrastructure is no, both is both. Okay. So if any of you want to vary your responses, knowing that would be great. So the interesting thing here is, what I'm seeing is most of the audience are using digital terrain modeling from both an infrastructure and a building perspective, which means is forming part of an integrated approach for or to BIM. Okay, not necessarily wanting to differentiate between buildings and infrastructure. So definitely a small b for BIM, not a big B for BIM. Okay, right, I'm going to close that poll and share that with you. So as you can see here, vast majority, almost 50% of you in the audience are using digital terrain modeling as part of the overall integrated process, which is brilliant as far as I'm concerned. Okay, so moving on. Who are Nemetschek? Well, Nemetschek is a software solutions company now. We've been in existence for over 50 years. We were founded in 1963. Our headquarters are in Munich. We are an open BIM pioneer, as it says there. We are comprised of 15 strong brands. Some of the brands that you see along the bottom there, you may or may not recognize. Allplan is the original brand of Nemetschek, and the most recent acquisition is that of RISA in America. So we have also SIA, SDS2, Celebra, you may know, Graphisoft, Maxon, Cinema 4D, so on and so forth. Allplan have been a leading AEC software provider for over 30 years and offer comprehensive BIM solutions for architecture, engineering, and construction. We're one of the founding members of the Open BIM movement. We've got over 400 employees in 9 countries, and that is growing. And again, over 190,000 users in 41 countries, and that is growing as well. What do we do? Anything that you can think of that involves modeling from an architecture, engineering, and construction process. Our particular forte is complicated structures, and I've coined a saying that which goes along the lines of, if you can model it, then we can reinforce it. The modeling engine that we have within Allplan itself is very comprehensive, and allows us to do many, many things. So we focus on structural and civil engineers. We are not constrained to modeling in just 3D. We do want people to work in 2D as well. Recognizing that drawing creation is a fundamental part of the process, we believe that annotating certainly certain drawings as you go, such as reinforcement, is a valuable time savings. This, we believe, still fits in with the BIM ethos. And then we've got that discrepancy resolution, we've got the integration two-way link with analysis and design, and we've got an extended workflow that pushes the boundaries not just with structure and architecture, but also within the civil engineering. So it's one of the few software solutions that has all of those main disciplines combined into one integrated environment. From a building perspective, it's Allplan covers from the simple to the quite complex, from the low story to the multi-story. From a bridge perspective, which is where obviously digital terrain modeling does come into its own, we have new bridges, old bridges, complicated and not so complicated. And from a civil engineering perspective, we can take into account tunnels and complicated flood or power generating structures. And again, digital terrain modeling factors into this side of things as well. So on to the main topic for today. So what are we looking to produce? So we're looking to produce a digital terrain model, but we're also looking to integrate that digital terrain model with horizontal alignments. And again, this is important how these all interact. So I've chosen a road as an alignment, but it doesn't have to be a road. It could be anything that is based on an alignment. So if you have a retaining wall, for instance, then certainly we can model the face of that retaining wall just as we model the road center line. The ability to cut and label along something like that is invaluable when it comes to creating or annotating structures or other objects such as roads. Okay. In Allplan, we have various ways to create those digital terrain files, not just constrained to one particular format. In many countries, there are free-to-use versions of maps. Here in the UK, we have an open source point listing that gives our Ordnance Survey maps height at 50-metre intervals. And in theory, if we were to put all of those tiles together, we could create a full-on digital terrain model of the United Kingdom. Now, even I am not that stupid to try and create something as big as that, to be fair. But the fact that we can bring them in as tiles and use them, again, means that we can use what we want to use and discard what we don't. It's no good doing all of this if we can't label or even add additional information to make the reading of those digital terrain models a little bit easier. So annotation comes in the form of contouring, labeling, and so on and so forth. Okay. So I've already mentioned here that we've got an alignment of sorts. That alignment we can use to create sections and profiles and see how those sections interact with our vertical road design, for instance. We can take that design and we can create slopes that are required for cut and fill purposes. And if we're generating slopes and we're cutting and we're filling, it would be nice to know how far out we are with our calculations or our design as to whether or not we're going to have to pay to have things taken away or pay to have soil brought back to the site. Okay, all of this we can do within Allplan. So here we are in Allplan. We are in the surroundings part of the program, which is okay. I'm just getting some warnings up on degraded audio quality. Hopefully you can still hear me okay. I haven't heard anything back from my colleagues yet, so we'll just carry on. So in Allplan itself, we have the ability to create alignments. Those alignments can or are based on straights, spirals, and curve objects. And all we're doing here is just controlling an alignment based on bearings, lengths, whether or not it's a spiral or an arc, and building them up steadily into a much bigger object. That object itself we will call a composite element, okay, which is essentially one object made up of many different objects, straights, spirals, or composite curves, and arcs. That forms the basis of any horizontal alignment. We can annotate that alignment based on setting out information. So for instance, lengths, angles, and start radiuses, etc. We can also annotate the alignment using chainages. So the chainage of this particular composite element obviously starts at 0 and then ends up at the end at 384.375 meters. Okay. So once we have the alignment, then we can move on and let's import some points. Now these points come in the format, in this particular case, with what we call with an extension called an RE1, which is going to pull in points in a certain format. Doesn't have to be an RE1 format, it can be other formats as well, but essentially it's an XYZ format. And that brings the points in. We are able then to create a mesh between those points fairly automatically. Okay. Once we have that mesh, we can do other things with it, for instance. Okay. So we can look at contouring. We can take our digital terrain model that we have in the background there, and then we can place lines or polylines essentially at 3D elevation. They are then derived from the points on the in the digital terrain model. So we don't do interpolation at this point, but we can actually, these are fairly what I would call sharp contours. We can employ contour smoothing if we want to. And then we can annotate those contours by selecting the contours that we want to cross and put numbers against for their elevation. If we have, for instance, a building, then we need to integrate that building with the digital terrain model. We can create, then once we have that integrated within the digital terrain model, Allplan will generate a series of interpolated points. Once we have those points, we can create, you can call it an island, or we can call it a void cut. So we can cut a portion out of the digital terrain model to take in the building itself. Okay, so we've just cut out from this model a whole load of soil based on the level that we've placed that building at. Hopefully that makes sense. From a perspective of looking at this in a combined way with the digital terrain on an alignment, okay, we are looking at two instances. We have the original digital terrain model, which is important because that means that's where we start from. And then we have this that we're working on at the moment, which is the edited form of the digital terrain model. Now I've just re-imported into this file my alignment, and I'm asking Allplan to generate a profile through that composite element, through the center line of my road, essentially. Okay. As you can see here then, what we've managed to do is at the various changes along the route, we have created a profile. And that is the digital terrain, obviously, as it progresses through the changes. You've got a lot of control here with regards to how this profile is created, with regards to colors and styles, and even ultimately the ability to combine other aspects of the design within the same profile cut. So if we then have a look at the vertical design when it comes to this, because what we need to do is we need to be able to ascertain where our alignment or what our alignment goes through from a vertical perspective. And I've just changed the color of this spline at the moment to red. Okay, so this is an approximate design. What I need to do then is take my 2D alignment that I have here, and I need to elevate it to the correct level. So this is going to create essentially a 3D spline based off a 2D alignment and a 2D profile. That 3D spline you will see progressing through the digital terrain. Those of you that can see the top left-hand part of my screen at the moment will see there's a lot of information that appears to be going into it. Recognizing that alignments sometimes have super elevation, in which case what we have here, we've created what we call a torsion trace. And what we're doing now is creating offsets to the alignment, again in 2D. And then we're going to reuse the torsion trace to provide 3D splines of those 2D elements. Now we're going to do this by using points, and we're going to use the generated torsion trace to help produce those. Ultimately, however, what we end up with when we join those points together are, as I mentioned, 3D splines, and we have a patch tool in Allplan where we can use those 3D splines and close off the ends using 3D lines to generate a patch which represents our design surface. Again, from a visualization perspective, it just helps to show what is happening with regards to the design. Recognizing that we don't need to have the masses of information all of the time, we can actually build that up step by step by step. Okay, so a patch is one of those tools that we can use to actually highlight where the road or the alignment actually goes. We're not playing. Okay, so let's try this. So now what we want to do is look at our generated offsets, which could be the front or back or higher up if it was a retaining wall, for instance. And we're going to want to integrate this now into our design. So we can take the surface that we've just developed and we can tell it some profiles for cut and for fill, and we can project those slopes, as it were, into the model and integrate some design surfaces with the original surface. So what we have here is, hopefully we can see the build-up. So we can see where the road cuts into the ground, and we can see roughly where the road needs to be built up. Okay. So apologies for some adverse mouse movement here. What I'm trying to show exactly is the path of the road and how that works with regards to the slopes, the batters for the different surfaces. Okay. So to date, we've seen a long section, and I'm going to show you now how we can create a series of cross sections along the route, and how this looks with the digital terrain model. So we can actually take slices through the route. Okay, and what Allplan is generating a series of sections along the route, and then we can activate these sections and we can create cross-sectional views based on parameters that I've entered for the various changes. So these are items that we can use to further document the design going forward. Again, but all of these are tools that are contained within Allplan itself. So next, once we have our some of our design profiles already taken care of, I would like to run some calculations based on the original model and the edited model. So first thing to do is to load the unedited model in the background and compare that with the edited model. I would like to put the results of what I'm calculating into two new submodels so that I can use those again as part of my documentation set. I can produce a listing of my cut and fill calculations. So here we can see that the cut is currently showing at just over 3,400 cubic meters, and that the fill is a lot less, which isn't very good. So we need to go back to the drawing board and rebalance out the cut and fill. Furthermore, what we can do is we can also look at the results of these calculations, and we can get an idea where the cut and where the fill is coming into play. So based off edited and unedited, and as you can see, there's even a surprising amount going on with regard over the building as well as the road itself. So we can use these diagrams to further help us with the the design process. So there are a few case studies where this has been used. Primarily, we're just going to sort of like focus in on some of the heavy civils. So digital terrain models can be used for tunneling. It can be used for water-based flood alleviation. It can be used for dam projects. And we have there's a case study on our website which you can go and download for that in that particular instance. Anywhere where there's a need to interact with the terrain, we can produce alignments and profiles and cross sections. At this moment, I would like to invite the audience for any questions they may have. If you can type those into the screen, the question panel, that would be brilliant. I would also like to add, I think, while I remember, when we were doing the island, the void cut for the building, I would also like to add that we can add in an external boundary as well, so that if the digital terrain is not a rectangular shape or a tiled shape, if it was, say, for instance, based on the actual shape of the site or the road or the retaining wall, then we can actually use a boundary object to cut the terrain back, so that it's not, we don't end up with unnecessarily and inaccurate triangles of the mesh. Okay. So I can see that some questions are coming in. I have one asking for more information with regards to the longitudinal profile, and also if the alignment is an add-on. Okay, so the alignment that you see there is all contained within Allplan itself. It operates to a local code based on I guess this is for the super elevation, to generate the necessary grades based on the design speed. Okay. That said, however, if that doesn't conform to your particular area, revised torsion traces can be produced manually, because all that is just a 2D representation of what needs to happen with the slope from the alignment itself. So another question about interoperability. So Land XML is used to convey information to other consultants on different systems. The digital terrain itself could be, again, supplied in point format XYZ, so that the two can be kept in tandem. You can take the design model and export the points out of that if you want to, and that way we can sort of like create the sort of like a unified sort of approach. The elevation, can we import elevation information from a 2D drawing? So that's going to be a little bit difficult to do without being able to intelligently elevate the points. Okay. what we would need to look at is the relationship between, say, for instance, a point mark and the text that describes the elevation of that point. Certainly done it in the past with 2D information, running a routine to elevate the points based on the text that is nearest to the point. That's very easily done and can be programmed. And I would probably hasten to add that there is a way of even integrating spreadsheets or Excel into this process to make it a lot easier to do this sort of stuff. Digital terrain modeling, but to introduce very quickly what Allplan can do. And Allplan can do a lot more than what we've just described here. But recognizing that the time constraints, we like to keep these to half an hour to 45 minutes, so it doesn't interfere with too much with people's working days. And by all means, keep those questions coming. Our next webinar is due to take place on the 13th of June and is entitled An Introduction to Tunneling with Allplan Engineering. And that will also highlight some of the integration possibilities with the digital terrain modeling as well. Okay. So we have now some more questions about future developments in road design. So future developments is something that is hard for us to convey because of who we are, what we do. If you've got ideas for future developments or the direction you would like to see Allplan go in, please email me, okay? Then I can take that to development and we can see where that fits in with the roadmap. And if we can convey that information back to you, then we will endeavor to do so, okay? Another question that's just come in, how can we import information into a DTM from a series of 3D splines instead of 3D points? Okay, right. The problem with a spline is that it is comprised of control points and other points that affect the degree of curvature or where that spline goes. If you imagine you are on site and you are taking levels across a field, say for instance, those levels form what is known as sometimes a string. If that string is a 3D line or a 3D polyline where the points are joined by straight lines, then we can read the vertices of that line and we can create points from it. I would not suggest to anybody to create information from interpreted results. So I would never suggest to create a digital terrain model from a set of contours, for instance, because contours are derived from the terrain. So you are instantly introducing assumptions into the design. If you're happy with those assumptions and know of those assumptions, then fine, not an issue, not a problem. That is your decision. It is not something that I would personally condone or even use, to be fair. So another question here, does Allplan import large point clouds from laser scanning? I would like to, I'll take that one offline a little bit later and discuss that one with you. We can import point cloud information if they are based on X, Y, and Z coordinates. However, recognizing that laser scans create lots of points in a very short, in a very small area, I would say that for certain applications, it is going to be far too much information that is required from a initial design perspective, or what Allplan can do at the moment. If those point clouds were decimated, so that we're no longer talking about 10 mil intervals, that we might be talking about 100 or 500 or even 1,000 millimeter intervals, then again, it's going to be a lot easier for Allplan to handle that amount of information at the moment. Bearing in mind that Allplan was not designed to take in point clouds from laser scanning. It can do with the right approach. Okay, so that's something that is called decimation within a point cloud environment, but it doesn't need to be, from my personal perspective, it shouldn't be an arbitrary decimation. It should be a controlled decimation of the point cloud. I've got a question coming in. Is it available BIM plus cloud? Not exactly sure what that question is all about. BIM plus is a cloud-based application, not necessarily, i.e. in the Internet of Things, not necessarily the ability to process sort of point clouds. So if you would like to elaborate on that question directly to myself, that would be brilliant. So back to where I was. We're just going to have a last few polls before we wrap up. So what I was wondering was, bearing in mind that we've only touched on the surface, excuse the deliberate pun there, of digital terrain modeling. Would you like to see more deep dive webinars? And if you would, send me your ideas to rpullinger@allplan.com. If you can put into the topic deep dive as the subject line, then I will be able to instantly recognize what those emails refer to, okay? And I'll compile a list, and then I will speak to my colleagues and we'll get something set up. And these will be independent of the technical webinars that we're producing at the moment, which are an introduction to, okay? So these will be ad hoc, as and when we can fit them in. But this is an idea that came to me last night with regards to trying to convey more information without actually these deep dives forming training examples, okay? What we don't want to do is substitute good training for these very quick 30-minute, 45-minute webinars, because there's only so much that we can cover without going overboard. So I'm going to share those. Vast majority of you are looking for more deep dives, which is good to know, good to see. There's a small majority of you that know what you're doing, or you find you're happy with how you're doing it. And again, I will respect that. And that's 5% of the attendees that we don't need to broadcast to. So that's good. That's good. My last poll of the day was this webinar too short? About right. Too long? So, i.e., would you have liked to? Are you expecting more from an introduction to, as opposed to less? So I'm going to give this one another. Okay, so the jury is out on this one, which I had a feeling it would be. But based on what we can show in the amount of time, yeah, okay. I'm going to close. All right. and share, because I'm like that. I'm honest and upfront. Yeah, so 50-50. Some like the length, others thought it was a little bit too short. Now, I know those are ones then that I would think that it's too short are also voting for more deep dive information, okay, which is what I thought. So, yeah, very useful, very obvious comment is the deep dive is useful for those already using Allplan. And I would imagine that most of that 50% there that are voted are already using Allplan. What I would say is, though, if you are interested in knowing more about what Allplan can do, please contact us. We will be in touch to find out if you do want to know more, if you do want to see more about what it can do, particularly from an integrated environment and with regards to various BIM levels, shall we say, in particular BIM level 3, and how it works with our BIM Plus platform. Please let us know, and we'll take it from there. Okay, so finally then, I'm going to wrap up today's webinar, and I'm going to say thank you very much for everyone that's been online. Yes, please catch us on the next webinar in about a month's time. That would be absolutely wonderful to see you there. In the meantime, 2 emails that you might like to take note of, myself and Jonathan Croft. Anything from a technical perspective, please do not hesitate to contact us. I'll stay online for a couple more minutes before closing the webinar, just to allow any more questions or comments to come through. And then we will say goodbye for now and let you get on with the rest of your day.